As I said in the first lecture, arguments are used for many purposes. And in the lecture just before this one, we saw that it can be used for persuasion and also for justification of various sorts. But persuasion and justification are not the only purposes for which arguments are given. Arguments are also given in order to explain things. So we're going to spend this lecture talking about explanation. Indeed, what we're going to try to do is to explain explanation. We explain things all the time. And I'm going to give an example that'll probably really tick off my co-teacher Ram because he's from Chapel Hill. But my example is somebody might ask, why did the Duke basketball team win the national championship in 2010? And the answer might be that they had great players and a great coach. And of course, they got lucky. You have to have some luck to win a national championship. But in any case, an explanation of that event is a reason why it happened. So to explain something is to give a reason why it happened or to answer a question about why it happened. Notice that when you explain something, you assume that it's true. It wouldn't make any sense to ask, why did Duke win the national championship in 2011? Because they didn't. You can only ask why this thing happened if it happened. So we've already got one difference between explanation and justification and persuasion. When you try to persuade someone to believe something, that thing doesn't have to be true and they don't have to have believed it in advance. When you justify something, right, you can justify belief in something that they don't already believe. But when you explain something, both the arguer and the audience are assuming that that thing happened, that the conclusion is true, and they're looking for the reasons why it happened. So if the goal of explanation is not to persuade or to justify, and the arguer and the audience both already believe the conclusion, then what's the point? What's the goal of explanation? The goal of explanation is to increase understanding, not to convince us that the conclusion is true, but to help us understand why it's true. And we can do that in a number of different ways. There are actually, according to Aristotle, 4 different types of causes, he would call them, but we would probably call them explanations. The first, he called efficient causation. We'll just call it causal explanation. And that tells you why something happened. Why did the bridge collapse? Because there was an earthquake. That explains why the bridge collapsed. The second type of explanation, he called teleological or purposeful explanation, because it's looking at the purpose or the telos or the goal. Why did Joe go to the grocery store? To buy milk. His goal of buying milk is what explains why he went to the grocery store. Third type of explanation is formal. Why does this peg not fit into this hole? And the answer is because the peg is square and the hole is round. That's why it doesn't fit in the hole, and that explains it. That helps you understand why it didn't fit. The fourth kind of explanation is material. Why is this golf club so light? Why does it weigh so little? The answer might be because it's made out of graphite. That helps you understand why the weight is so low on this golf club. It would be a lot heavier if it were made out of steel. So we can have 4 different types of explanation. We can have causal, we can have teleological, we can have formal, and we can have material. And all of those different types of explanation are aimed at helping us to understand why something happened. So did you hear that train whistle? We want to ask, why does the train emit such a loud noise? Well, one answer might be that what causes it to make that noise is that the conductor pulls a lever on the train which creates that noise. That would be a causal explanation. Another explanation might be the teleological explanation. The train was crossing an intersection with cars and wanted the cars to know that they're coming. Another explanation might be a formal explanation, because the whistle on the top of the train has a certain shape that makes the air come out with a certain vibration. And a final explanation might be a material explanation, because air has a certain density and a certain material that makes it create that kind of sound. So we can give all four types of explanations for the same event. Here's another example where we can apply all four types of explanation to a single event. Joe jumped out of an airplane. That's what caused him to fall. But then, why did he jump out of the airplane? To get excitement. Why did he fall so fast? Because of his shape, it was aerodynamic, and because of the material that he was made out of, heavy flesh, which was a lot denser than the surrounding air. So all four of those factors go into an explanation of why Joe fell when he jumped out of the airplane. So next we need to talk about the forms of explanation. You can actually give explanations in several different forms. For example, if somebody said, well, why did you move to Duke? I might tell a story about things that happened before I moved to Duke that led me to want to move to Duke, and I could talk about moving to Duke and all the nice people here and so on. You can give explanations in the form of narratives like that. But notice that that's not going to imply that everybody in similar circumstances is going to behave in exactly the same way. So you're not going to get general principles out of those types of narrative explanations. But other explanations are given in the form of arguments, and that's the kind that we're going to be interested in here. The form in which explanations occur in arguments is really pretty simple. One premise usually states some kind of general principle that can apply to a lot of different situations. And then the second premise talks about the current situation and says that those types of features that the principle mentions are instantiated in this case. And then the conclusion says that explains why it happened this way in this case. For example, if we want to know why objects fall, right? So there's a book and it falls. We want to explain that. We need to cite a general principle. But notice that not all objects fall. Some objects actually rise. Helium balloons rise. So we need a principle that's going to explain why some objects fall and other objects rise. Then we'll understand why helium balloons rise, just to stick with that example. And the answer is that when an object is suspended freely in a medium, where the medium is more dense than the object, then it rises. And when an object is suspended freely in a medium where the object is more dense than the medium, then it falls. So you can explain why helium balloons rise by having as your first premise, whenever an object is freely suspended in a medium, like a gas or a liquid, and the medium is more dense than the object, then the object rises. Now let's talk about the circumstances in this particular case. The helium balloon is less dense than the air that surrounds it. Therefore, the helium balloon rises. And that explains why the helium balloon rises, and you can see how you give another argument to explain why the book fell. Now, this form of argument gives some people the impression that any generalization can be used for explanation, but that's not quite right. One example is Bode's law. Bode's law says that 0.4 plus 0.3 times 2 to the n can be used to predict all the distances between planets and the sun, where n is the number of the planet. So if n is Venus, then n is 0, Earth is 1, Mars is 2, and so on. This law was actually used to predict both the largest asteroid in the asteroid belt, Ceres, and also Uranus. So this law is a generalization that held for all the planets that they knew in Bode's day, and also used to predict new observations of planets. Pretty cool. It actually turns out to fail when you get to other planets, including Neptune and Pluto, but still it worked pretty well for the data that they had. But nobody thought that this law explained why the planets were that far from the sun. They happened to fall in that pattern. It could be used to predict, but it didn't explain why they were the distance that they actually were from the sun. So Bode's law gives you a nice example where you can have a generalization and a prediction without explanation. Now here's an example where you can have explanation without prediction. Just think of a woman who has AIDS and gets pregnant and gives birth, and her child has AIDS too. Now, that would explain why the child was born with AIDS. But it won't predict that the child will get AIDS, because actually less than 50% of the children who are born to mothers who have AIDS themselves. So you can't get a prediction out of that disease state, but you can get an explanation when the child does in fact have AIDS. And notice also that the fact that the mother has AIDS doesn't justify you in believing that the child has AIDS. What justifies you in believing that the child has AIDS is that you test the child's blood and find HIV in the blood. So here we have an example where there's an explanation without justification or prediction. And so explanation is very different from those other uses of argument. So then, more positively, what is the goal of explanation? Well, the goal of explanation is to fit this particular phenomenon into a general pattern. And that's what all of these explanations do. Why do you want to fit them into a general pattern? Is simply to increase your understanding of why they came about. They came about because they fit into this particular type of pattern. And this kind of understanding them, fitting them into a well-known pattern, is useful because most of the things that we want to explain are kind of weird, unusual, bewildering, surprising phenomenon. That's when you need an explanation, because fitting into the pattern makes it a little less bewildering, a little less surprising, because it shows that it's kind of like other things that have happened before. And that's what Bode's law does not do. Because Bode's law, although it holds for all the planets that had been observed in the day of Bode, it doesn't explain anything else. It doesn't fit it into a larger pattern with other planets around other solar systems. And now that we've discovered planets, we've found many planets around other stars that don't seem to follow Bode's law at all. So it doesn't fit our solar system into a general pattern, and that's why, even though it's a generalization and was used to predict other planets, it does not provide an explanation of why the planets are certain distances from the sun. So now we've learned a little bit about what explanation is and what explanation is not. Explanation is an attempt to fit a particular phenomenon into a general pattern in order to increase our understanding of why it happened and to remove bewilderment or surprise. Explanation is not persuasion or justification or generalization or prediction. Those are other uses of argument. So we've seen quite a variety of different uses of argument, but we've only scratched the surface. There can be lots more and lots more to say about each of these. So if you want to learn more about these purposes of argument, a good place to start would be Chapter 1 of the accompanying text, Understanding Arguments. But we're going to leave this topic for now and turn to a separate topic. In order to understand something, you want to know not just its purpose, but the material out of which it's made. So the next few lectures will be about the material out of which arguments are made, namely language.